If I see the first question, it says the bisectors of angle A and B of a quadrilateral ABCD intersect each other at P, and of B and C at Q, and C and D at R, and that of D and A at point S. We have to figure out this quadrilateral so formed by the bisector is what. So for that, we will draw a quadrilateral. Let's say I draw any quadrilateral here, keeping in mind that it is not a rhombus or square or parallelogram. So any quadrilateral. So and I name this as A, B, C, D, and then we have to draw the bisectors of this angle. So the bisector of angle A and angle B is this. Bisector of angle C and angle D are this. So as I can see, the bisectors of A and B are meeting at P, B and C at Q, C and what's that? This is R and this is S. We have to figure out what kind of quadrilateral is this. Now remember, first of all, had this quadrilateral been given a parallelogram, in that case, this PQRS would have been a rectangle. But that's not the case over here. It's any quadrilateral. So we cannot say that PQRS is a rectangle. So what I'm going to do is we have these as equal angles. I name this as 1. These two are equal. I name 2. These two are equal. So angle 3. And similarly, these two are equal. So this is angle 4. Now, first of all, what I can say that the sum of four angles of a quadrilateral is how much? Is equal to 360 degree. Now check here. I can replace angle A with twice of angle 1. And this is because we are given that these are bisector. So I can write down this being angle A can be replaced with twice angle 1, angle B can be replaced with twice angle 2, and angle C can be replaced with twice angle 3, and angle D will be twice angle, this is twice angle 4 is equal to 360 degree. On taking 2 common, what do we get? Angle 1 plus angle 2 plus angle 3 plus angle 4 should be 360 divided by 2, that is 180. Now check for this triangle. I'm talking about, say, this triangle here. You know that sum of three angles of this triangle will be how much? 180 degree. So we can say that if I ask you what is angle 1 plus angle 2, right? If I ask you just what is angle 1 plus angle 2, it has to be what? 180 minus angle P. And same way, if I ask you what about angle 3 and angle 4 as, right, angle 3 and angle 4, check for this quadrilateral, now, sorry, triangle. I'm talking about this triangle. So you should say that angle 3 plus angle 4 plus angle R is how much? That's 180. Therefore, 3 plus 4 will be 180 minus the third angle, that is R, and that is equal to 180. So I can see opposite side, same sign get cancelled. In the next step, I'm transposing P and R to the other side. So let 180 be over here. P on transposing other side become positive and R is positive. So we got this as 180 degree. So we'll say that a quadrilateral, right, whose the quadrilateral so formed that we are talking about this PQRS quadrilateral so formed where the opposite angles are supplementary. That's what it means, that as you can see from here, we proved the sum of the opposite angles of this quadrilateral as how much? 180 degree. So therefore, D is the correct option in this case. In the second question, it says APB and CQD are two parallel lines. Then the bisectors of the angle APQ, BPQ, CQ, APQ, PPQ, CQP, and PQD. So that means we can figure out only when we draw parallel lines. So I made this one parallel line and one line, and this is the parallel. So this is first line is named APQ. This is APQ, and the other is what? CQD. So this is C. I can name it here. That's Q and D. This is not a midpoint, right? So that's why I displaced, I didn't keep it mid at some midpoint. Now we have to find the bisectors of APB. That means I need to join PQ, right? Then only we can get. So bisector of this, this, and this. So let's draw the bisectors first. I'm drawing the bisector of this. And so we have to draw the bisectors of interior angles, right? So let's make it like this. Okay, and they are meeting not given, so I can take PQ, say this is R and this is S. Now what we have to figure out is what kind of quadrilateral is this. That's what we have to figure out. So let's, it's actually a rectangle, but let's see how we are going to do. I'm going to take this angle as say 1, this as say 2, and this angle as 3. And these angles are equal, right? It's a bisector, so know that. So first of all, look into this part only. Like this is these two are parallel lines, right? These two are parallel lines, and this is a transversal. So from here, what you can see that this angle, this whole angle, will be equal to this angle. That is by alternate interior angle. We are going to use this concept. So that's what I'm going to write. I will write angle. This is angle APQ is equal to angle PQD, and that's by alternate interior angles. Now APQ is what? APQ is twice angle 1 and PQD is what? That is twice angle 2. So these two get cancelled. So we got angle 1 is equal to angle 2. Now you can check from the figure what you have proved here. Consider this line and this line and this being the transversal. Check here where you have proved angle 1 is equal to angle 2. That implies these two lines has to be parallel. So now we can directly say that this is PS is parallel to QR. And similarly, we don't have to do the same thing in geometry. We don't do the same step. So we'll say similarly, that is the other part, that is PR is parallel to SQ. So check what you have done. We have proved this being parallel to this, and this you have proved parallel to this. So therefore it becomes a parallelogram. So now I can say, as you can see, that if the same pair of opposite sides are equal and parallel, so it's a parallelogram. No, not same pair. Two pairs of opposite sides we prove parallel. So now therefore we can say PQRS is a parallelogram. But then it's the final result is not this. We have, as I said, it's a rectangle. So for that, I'll have to do one more step. Check here. You can see that this line is given parallel to this. Considering these two as the transversal, what you can say that this whole angle and this whole angle, right, will be supplementary. Reason is co-interior angle. So that's what I'm going to write. I write angle. This is angle APQ plus angle CQP is equal to 180. That is co-interior angle. Same as the previous way, we are going to replace this angle with twice angle 1, twice angle 1, and this by twice angle 3 is equal to 180 degree. So angle 1 plus angle 3 should be, on taking 2 common and dividing by 2, is 90. Now look into this triangle. I'm talking about this triangle. So you can see that in this triangle, you know that sum of two angles is how much? 90 degrees. So the third angle has to be 90 by property. But we know that when three sum of three angles of a triangle is 180 degree, if two of them is 90, so the third will be 90. So that is angle S is equal to 90 degree. So let's mark this equation as 1. I'm talking about this as equation 1 and this as 2. We have proved this is a parallelogram, and a parallelogram whose one angle is 90 degrees what? Is a rectangle. So This is what our correct answer, that is a rectangle. Property used is a parallelogram whose one angle is 90° is a rectangle. This question says, which of the following is not true for parallelogram? Remember, we have to get not true, right? Not true is what we have to get for the properties of parallelogram. So let's make a parallelogram so as you to understand. So this is ABCD as a parallelogram. The first is opposite sides are equal. That's true. Opposite sides of parallelogram are equal. Opposite angles are equal. Yes, angle A is equal to angle C and angle B is equal to angle D. Then opposite angles are bisected by the diagonal. That's not true, right? Let's say if I join this AC, right? Here, these two angles may not be equal, right? Angle 3 may not be equal to 4 or angle 1 may not be equal. This is true in case of rhombus, right? Rhombus and square, right? In case of a rhombus and a square, the diagonals bisect opposite angles. So this is incorrect. Option C, diagonals bisect each other is true. Like say if I join the other diagonal over here, as if I join BD over here, taking O is the point of intersection, this is true that AO is equal to OC and OB is equal to OD. So we just had to select the incorrect, and the incorrect we got this as, this is the option C is incorrect in this case. And then the next question it says, the diagonal AC and BD of a parallelogram ABCD intersect each other at point O. So let's begin with making a parallelogram. This I made a parallelogram and named it ABCD. And then we have to join its diagonals AC and BD, which intersect at O. So let's say this is AC and this being BD are the diagonals and they're intersecting, and the point of intersection is what we have to know as O. Further, I can see the angle DAC is mentioned as 32°. So let's write DAC. This angle is given as 32°. And we have angle AOB as 70°. AOB, this angle as 70°. And what we have to find out is the value of angle DBC. So where is DBC? Is check DBC. This angle is what we have to find out. Now, what you can see from here, let's say if I write O here, we know that these two lines are parallel, right? Here, AD is parallel to BC, and considering this as the transversal over here, what you can say that this angle and this angle will be equal by alternate interior angle. So this is 72. Now check, in order to get this angle, we are going to use angle sum property, but not before finding this angle using linear pair. It should be how much? 110. Sum of adjacent angles in a straight line are supplementary. So this is 110. So now we have to get this angle. So we can apply this property, that is the sum of three angles of a triangle is 180. And then from here, we will subtract the value of this, which is 142, right? Sum of these three angles. Let's say I write this as X, and I would explain you that here in this triangle, that is triangle BOC, we have X plus 110 plus 32° should give you 180°. And the reason is in angle sum property. So this is X plus 142 is equal to 180. On transposing 142 to the other side, it will be minus 142. So it should give you how much? From 180, we are going to subtract 142. So it's 38°. So we'll say that C is the correct option in this case. And when I come to the next question, it says D and E are the midpoints of the sides AB and AC. So why not make a triangle first? I take a triangle and I name this as ABC. Further, we are given D is the midpoint. Let's say D is the midpoint of AB. That's right. I read it. Yeah, and E is the midpoint, yeah, for the other side. That is AC here. And further DE is produced, so we can produce DE, let's say joining D with E, and it is produced further. Okay. Further, it says that what we have, D is produced to F, that's done. To prove that CF is equal and parallel to DA, CF, need to join CF. So that means through C, we will draw a line, right? Through C, we will draw a line. Let's make a line first. Okay. And I name this as F as for the question. This is the point F. So it says that CF is equal and parallel to DA. That means DA and CF is equal and it is parallel. That's what. So for that, what additional information is needed? So one thing is clear that we need to prove this figure a parallelogram. This part only, right? Why should I say that this being a parallelogram? Because if I prove this a parallelogram, if I prove this figure a parallelogram, then I can say that this will be parallel to this, implies that parts of parallel lines are parallel. So that means it is parallel to DF. Further, if it is this is equal to this, that means if I proved BD is equal to CF, and since BD is equal to AB, so we can prove these two as well as equal. So this is what we need to prove, right? That means we need to prove this figure a parallelogram. So in order to prove this figure as a parallelogram, what additional information is needed? Let's figure out. What we know that line joining the midpoints of two sides of a triangle is parallel to the third side and half the third side. So this DE is parallel to BC, right? So if DE is parallel to BC, that implies parts of parallel line are parallel. So DF is parallel to BC, but then DF is not equal to BC, right? In fact, DF is half of BC, but I need to prove this being equal to BC, and that is only possible if we know that these two are equal, right? If these two are equal, then we can say that it is a parallelogram. So where is that information? I can see that we need DE is equal to EF. Is there an option? Yes, DE is equal to EF. So you see that if you prove that this is equal to this, that means from this I can say that DF is equal to BC. And if it is equal to BC, if it is equal as well as parallel to BC, so it results to give this figure a parallelogram. It results to give you this figure a parallelogram. And if this is parallelogram, that means you can write BD is equal to CF. That means BD, which is equal to AD as per the question. So I can replace BD with AD is equal to CF. And since BD is parallel to CF by opposite sides of parallelogram, I can say that AD, which is parts of parallel line, will be parallel to CF. So that's what we have to do in this question. Now, before we read this question, let's understand a few properties. The first one is this. Let's say we can see that by joining the midpoints of the sides of any quadrilateral. Well, this is any quadrilateral. What do we obtain? We obtain a parallelogram. So line joining the midpoints of the sides of any quadrilateral will results to give you a parallelogram. Now, second is this. As you can see here that I've taken a rhombus. This outside is a rhombus, right? This is a rhombus. And if you join their midpoints, you will obtain a rectangle. So line joining the midpoints of a rhombus will result to give you a rectangle. And there is a converse of this. That means if outside is given a rectangle and if you join their midpoints, you get a rhombus. So that means line joining the midpoints of the sides of a rectangle is a rhombus. And the fourth one is this, that is line joining the midpoints of a square will result to give you a square only. Right, so outside and inside is also a square. Now let's read the question now. It says the quadrilateral formed by joining the midpoints of the sides of a quadrilateral PQRS taken in order is a rectangle. Well, the result is a rectangle. That means the inside is a rectangle. Inside is a rectangle. That means if I see the figure, it's the third one, right? Inside is a rectangle, then what is that outside is the question, right? That's what you should read the question carefully. So we'll say that if it is inside a rectangle, so outside has to be a rhombus. Now check, you may say, sir, this is not a rhombus, and rhombus property is not given here. Well, what you can see that this is true for this property, right? So the diagonals of PQRS, right? The outside, that is PQRS, are perpendicular. So is for the rhombus. Well, you may say that is for kite as well. That's very true. Even in case of a kite, if you join the midpoints of, let me show you if I can make a kite over here to explain this. I'll make a kite. Okay. This being longer, this is longer than this. Then if you join the midpoints of this, it results to give you a rectangle as well, right? So whether it's a kite or a rhombus, or maybe just that the diagonals are perpendicular, it results to give you a rectangle. So this is the correct answer in this case. Now, before we read this question, there are a few properties we need to discuss first. As I can see that you have shown here already. So if this is this white one, if this one is any quadrilateral, right? And so these being the midpoints, so if I join the midpoints of the sides of the quadrilateral, we obtain a parallelogram. That means the quadrilateral obtained by joining the midpoints of the sides of any quadrilateral, well, this is any quadrilateral, not special type of quadrilateral, that results to give you parallelogram. Now coming to the next, you should know that line joining the midpoints of the sides of a rhombus will results to give you a rectangle. So if outside is a rhombus and if I join their midpoints, we obtain a rectangle. Now third, you should look into this one, the converse of that. If you're joining the midpoints, if you're joining the midpoints of a rectangle, like the outside is if it is a rectangle, then the quadrilateral obtained by joining their midpoints would results to give you a rhombus. That's a converse of the previous. And say the fourth part is this, that if you are given a square and if you join the midpoints of these sides, it results to give you a square only. So here the inside and outside is a square. Now let's read the question. It says the quadrilateral formed by joining the midpoints of the sides of a quadrilateral PQRS taken in order is a rhombus. So the result is rhombus, right? So we'll go for this one. So we are given that after joining the midpoints, don't get confused, it's not the outside one, right? They are saying that after joining the midpoints of the sides, right? After joining the, oh, yeah, taken in order is a rhombus, right? After joining the midpoint, the result is a rhombus. So what is that quadrilateral whose midpoints were joined? So it has to be a rectangle. As you can see, this is a rectangle. So yes, so quadrilateral. Okay, now check again. So you can see that we have to look for a rectangle here. You may say that these are not rectangles. This is also not a rectangle, but look into this. This is the property of a rectangle, that here the diagonals bisect the diagonals are equal. And in the next question, we have already discussed the figure obtained by joining the midpoints of a rhombus taken in order. So I can see that this is a rhombus. By joining the midpoints of a rhombus, what do we obtain? We obtain a rectangle. So B is the correct option in this case.